Okay, so when you hear the word secure private network, especially in the cloud, you probably picture all these complex firewalls, layers and layers of protection. But what if I told you the biggest secret to rock-solid AWS security isn't about adding stuff, but about taking one super simple thing away? Let's dig in.
So let's start with a question that sounds like a total contradiction. How is a completely locked down private network basically the same as a wide open public one? I know, it sounds weird, but the answer to this little riddle is the absolute key to understanding how cloud security really works.
And boom, here it is. This is the punchline. A private subnet is for all intents and purposes exactly the same as a public one. The only, and I mean only difference, is that it's missing one single component: the internet gateway. That's it. That is the entire secret. So let's break down what that actually means. This one simple idea, this concept of removal, it's really the foundation of your entire virtual cloud. It's not about adding all this crazy complexity. It's about deeply understanding one fundamental building block.
So everything we're talking about lives inside an Amazon VPC, which stands for Virtual Private Cloud. The easiest way to wrap your head around this is to think of a VPC as your own private bank building in the cloud. It's this completely isolated structure where you can store all your valuable digital stuff totally separate from everybody else on AWS.
Now, just like any good bank, our VPC needs different rooms for different purposes. And this brings us to the core concept: public versus private. Let's stick with our analogy. Think of it as the bank's public lobby versus its high-security Fort Knox-style vault. And here you can see that one critical difference in black and white. The public subnet, our lobby, it has a front door leading right out to the street. That door is the internet gateway. The private subnet, our vault, well, it just doesn't have that door. No door means no way in from the public internet. That is literally the only structural difference. And this is exactly why you need both. Your public-facing website, the thing customers need to be able to get to, that lives in the public subnet, the lobby. But all your sensitive stuff, like customer data, that stays locked away tight in the private subnet, the vault, completely shielded from the outside world. Now, just a quick but super important technical rule when you're setting this up. Each subnet has to have its own unique address range, which is called a CIDR block. It's just like in our bank, right? You can't have two different rooms with the exact same room number. It would be chaos. Okay, so we know we need to remove that door to the internet, but how do we actually do it? Well, it all comes down to something called the route table. You can think of this as the GPS or the traffic controller for all the data moving around inside our network. Here's the catch. By default, whenever you create a new subnet, AWS automatically gives it directions that lead straight to the public internet. Now, that's great for our public lobby, but for our secure vault, we've got to give it a totally different set of directions. And this is what those default directions look like. That first line just lets stuff talk to each other inside the network. But that second line, that's the one we care about. 0.0.0.0/0 basically means anything and everything else. And it's being pointed right at the IGW, the internet gateway. That's our open door.
So the solution is beautifully simple. We just create a brand new route table just for our private subnet, and we just delete that second line. That's it. Now, the only rule is that traffic can move around locally, inside the VPC. The road to the public internet, it's just gone. The door is sealed shut.
Sealing the door is step one. Step two is adding another layer of security. We're going to post a dedicated guard at the door of the vault. In AWS, this guard is called a Network ACL, and it acts like a firewall for the entire subnet. But here's another one of those surprising little details. By default, this guard is, well, kind of useless. The Network ACL is configured right out of the box to allow all traffic, both in and out, to just pass right through. Not exactly the Fort Knox security we were hoping for, right? You can see it right here in the default rules. Rule 100 explicitly says allow all traffic from any source. Now, there is a deny rule at the end, but since the rules are checked in order, that first allow rule means the floodgates are effectively wide open. So the fix, once again, is a tiny change with a huge impact. We just create a new Network ACL, and we change that very first rule from allow to deny. Now, the default behavior is that absolutely nothing gets in and nothing gets out. It's a total lockdown. So let's bring this all home. Why does this simple secret, this idea of security by removal, matter so much? Because it completely changes how we should approach building secure systems in the cloud. You want to know the most surprising part of this whole thing? Setting up this entire secure private subnet from the route table all the way to the ACL took just 30 minutes. This isn't some massive, months-long engineering project. Powerful, effective security can be incredibly simple and fast to implement. And that really brings us to the core takeaway. We're so often taught that to make something more secure, we have to add more things, more tools, more rules, more complexity. But what we've just seen is that sometimes elite-level security comes from strategically removing a single point of access. It's security by subtraction.
So that leaves us with one final question to think about. If creating a truly secure, isolated space in the cloud is this straightforward, what else in our work, or heck, even in our lives, are we making way more complicated than it needs to be? Where else could we achieve more simply by doing less? It's a pretty powerful idea. Thanks for tuning in.